All right, so here's a video to show you how to kind of analyze and graph parametric equations. As promised, I chose something that was non-trig, and then I'm going to do a trig one for you. Our first pair would be x equals square root of t plus 2 and y equals 1 over t. And you can see over to the side I did a t chart with 3 columns, t, x, and y. Let's look at the domain for t first of all. If I say that t has to be greater than or equal to -2, then that's going to work for both x and y. So that's my one restriction for x. My restriction for y is that t cannot be 0. So in choosing values, I think I'll just go ahead and start with -2, and then we can go to, -1, skip over 0, and then 1 and 2. And if you want to choose other values to help you with your graph, that's fine, but that's going to work for me for now. You're going to find in some AP or word type problems t, which stands for time. Usually it's the time parameter in the x and y, so you not only know where the point is, you know when it gets there. That t will usually be greater than or equal to 0, but I thought I would just take these as they are and work from there. So if t is -2, then x is 0, y is -1/2, t is -1, x is 1, y is -1. Notice I'm skipping over 0, but there are a lot of values, an infinite number of values I could use between -1 and 1. When x is 1, or when t is 1, x is √3, and y is 1. And then at 2, you have the point 2 1/2. So if I come over here, and this is sometimes easier to do with graph paper, but you don't have to. My initial point is 0, -1/2. So I think I'm going to go by 2's here, just so this isn't so cramped up. And that'll be good to start with. So the point 0, -1/2 would be right there. That's my actual original point on the graph. From there, I'm going to go to 1, -1. So it appears to be going downward. And then it will, something's going to happen between -1 and 1, because if you can't put in something, usually there's a hole or there's an asymptote. This is leading me to think right here that there's going to be an asymptote, but I don't really know for sure what's going on. This is kind of a messy one, and I'm glad I chose it just because it's going to be a little bit harder than the ones you have to do. √3, I don't know, 1.7-ish 1, so I'm up here. And then 2 1/2. Wow. Okay, those points don't look like they have anything going for them. And so because I'm a little bit confused on how to connect them, I'm going to do what's called eliminating the parameter. So what you usually do is solve for t in terms of x. So I'm going to take this equation, come down here, and get x squared minus 2 equals t. Then I'm going to take it and substitute it in for t in the y equals equation, and I get y equals 1 over x squared minus 2. So that's a rational function, has asymptotes. Okay, that makes sense, at plus or minus √2. Because, and let's kind of go back up here. If t is greater than or equal to -2, then my domain for x is x greater than or equal to 0. So I don't really care at all what's going on in the second and third quadrant because it's not in my domain. My range, if t can't be 0, the only thing y can't be is 0. So my range would be -∞ to 0, union 0 to infinity. So that's going to help me when I come down here with this graph. Looking at the graph without the parameter, oh, I love it when I hit something and it pops up. There we go. Okay, and I know that I have asymptotes at x equals plus or minus root 2. Because x can't be less than 0, I'm going to ignore that other asymptote, and I'm going to come in here where I think root 2 would be, which is about 1.4, and bring in an asymptote. And now those 4 points that I have graphed all of a sudden make sense. So I'm going to start here and head down that way. If you remember, when graphing parametric equations, you have to show direction. So this is when t equals -1/2, so time moves in a forward direction. So I end up at -infinity, and then somehow with magic it comes back around, starts up here at the asymptote, and because y can't be 0, then my x-axis is also an asymptote, and let me show the arrows that way. So there's my graph of my parametric equation. It starts at the point 0, -1/2, approaches an asymptote at x equals root 2, and then the graph begins again on the right side of x equals root 2 and approaches 0 as it goes to infinity. So there's your trig graph, and I think you'll find that that one again is a little bit more difficult than the ones you have to do. Okay? All right, actually the trig graph is easier. We've got x equals 3 cosine t minus 2. T is all real numbers for both of these because your domain for trig is all real numbers for sine and cosine. I'll be specific there. Okay, so you know what the graph of cosine looks like. It has a range from -1 to 1. If I multiply that times 3, it's now from -3 to 3 inclusive. And if I subtract 2 from that, then my x value should range from -5 inclusive to 1. Coming down to the y, it's just taking the sine graph from -1 to 1 and flipping it, which doesn't really change those y values, but then multiplying it by 2 gives you a vertical stretch from -2 to 2. So that part's pretty easy. Coming over to my t-chart, I am not going to use negative values here because this is circular in a way, so it's just going to repeat on itself every 2 pi. And I'm not going to use integers. I'm going to use things that are unit circle friendly. So when I see this, I'm usually just going to slap down 0, pi halves, pi, 3 pi halves, and 2 pi. And then my x and y values here will be 1, 0, -2, -2, -5, 0, -2, +2, and then back to 1, 0. Okay, so coming over here, again, I think I'm going to use a little bit of a scale here. So 1, 2, 3, 1, 2, 3. I think I have to go to -5 over here. So 1, 2, 3, 4, 5. I used all of that. And then down to -2. Okay, so I'm going to start my graph at 1, 0. From 1, 0, I'm going to go to -2, -2, and then to 5, 0. So you can kind of feel the fact that I'm going clockwise. -2, +2 brings me up here, and then back to 1, 0. And it really wouldn't matter what values you put in, you're always going to trace this path over and over and over again. And you can see your domain and range from -5 to 1, and you can see your y values from -2 up to 2. It looks like we have the graph of an ellipse. Notice this time that I really didn't need to eliminate the parameter to get a feel of what my actual graph was. I'm going to put my arrows in to show my direction. Again, this is just going to repeat over and over and over itself. And now I'm going to eliminate the parameter, which is kind of cool. It's very, very different. I am not going to solve for t like I do on a non-trig. I'm going to solve for the trig. So in this case, the cosine of t in terms of x is x plus 2 divided by 3. And to solve for the sine of t, I get y over negative 2. Okay? So from there, we're always going to use an identity, and I think you have one on your homework that deals with secant and tangent, and you know that identity as well, so just make that adjustment accordingly. But cosine squared plus sine squared equals 1. Pretty cool? And so if you square both sides, then you get x plus 2 quantity squared over 9, replacing the cosine squared. And when you square both sides here, you get sine squared equals y squared over 4. And that looks like an ellipse to me. The center of the ellipse is negative 2, 0. Let's come over here. Negative 2, 0. X marks the spot. There's your center. Your horizontal distance from the center is 3. Yep, 1, 2, 3, 1, 2, 3. And your vertical distance is 2, 1, 2, 1, 2. There you go. So you've got your graph. You've got your equation with the parameter eliminated, which is obviously easier to graph, but it doesn't tell you where the point is at a certain time, and it doesn't give you any direction. It just gives you a graph. Hope this helps. See you tomorrow.